Hello. Can you hear me?
Hello?
Yeah. Can you hear me now?
Everything was it was on mute for some reason.
Oh, okay. So how was your New Year?
Oh yeah, it was good. Just spent some time with a friend.
Okay. Mm. Okay. Let's start with Surds. I have prepared some of the content that is related to your topic. So let's see
Okay.
what is that here. So we'll be starting first with the types of number. As we know that real number, all the numbers that in real life we used to given by the name the real number, and real number is having two parts. One we used to call rational number, and other we used to call irrational number. A rational number means simply if any number we can write in the form of p over q. Like as you can see an example, 1 over 4 or 3 and 1 over 2 or minus 7. Minus 7 can be written as minus 7 over 1. So that is why any number that can be written in the form of p over q, where q never be 0. So if we can write in this form, so q cannot be 0, never be 0, because if you are putting q equal to 0, p over q become undefined. So this one is the definition of a rational number. Now, irrational number is a number which is non-terminating and non-repeating, like any number in the squared form, like a square root 2, or like a number that is square root 5 or pi. These all are called irrational number. Means irrational number means that number is always non-repeating and non-terminating, just opposite to the rational number. So we are having some symbols to represent. Usually we used to write a real number with the capital R, and the irrational number we used to represent by q, and integers we used to represent by the rational number we used to write by z, or like z plus or z minus for the positive integer, for the negative integer. So in the book you might have seen there are different symbols. Here you can see this, what are the symbols you have. So we used to write n for the natural number that starts from 1, it goes to infinity, and z that we used to represent with the negative integers. If simply z is there, we used to write as only the integers. If z plus will be there, so that means it is positive integer, means after 1, after 0, it starts from 1 to onwards. And if z minus will be there, so you can say it is negative integer. So negative and positive both will be here at z. And q is for rational number, r is for real number. So these are the way that we are going to represent. And if you will write in the form of the Venn diagram form, so you know that this one is universal set. So we can say n is the subset of z, that is the set of integers and natural numbers, and z is the subset of q, that is a rational number, and all these numbers are subset of a real number. So we can say in this form of the Venn diagram. So these are the symbols to write in this form. Let's go from here. So here we can write the in the Venn diagram forms. So how we can replace out of all these numbers, can you recognize which one is a real number, which is a rational number, and which is integers out of all these given numbers?
Um So wouldn't a 3, that would
Three.
be a real number?
Yeah, that's right. So
No, no,
three will be a real
yeah.
number. So see the all these numbers are real number, but you need to recognize which one is real. If you will say real, all these are real. But out of
Mhm.
these, which number is integer, which number is rational?
Oh,
Yeah,
okay. So a rational number, that would be 3,
three.
right?
Yeah, three is integer. As we know that integers means -1, -2, -3, 0, 1, 2, 3, all are integer.
Mm-hmm.
All integers are also a rational number.
Rational number and also real numbers. Okay.
Yeah, that's right.
Oh, I get the graph.
Mhm.
Um, so what are the other ones?
Let's start from 0.7. So what is 0.7? Out of all these three categories, in which category we can particularly identify it?
Integers.
0.7 like integers means a complete number like a 2, 3 or -10. It should not be
Okay.
decimal. So
Oh,
it
okay.
comes in a
Irrational.
rational number. Like,
Sorry, can you explain to me the meanings of each one again? Because I think I
okay,
forgot
yeah, sure. Just
the
wait a
integers.
minute. Yeah, sure. And let's start from the natural number. Natural number starts from 1 and it goes to infinity. So
Okay.
1, 2, 3, 4, 5, so on, all are natural number. And z, we used to represent by z. So we can say z is a set of integers. Integers means it starts from minus infinity and it will goes to plus infinity. In between, there would be like a complete number. Integers means it should not be in decimal form. It should not be in fraction form. It must be like a -100 or 0 or like a +100 or 500. It's a complete number. It's not
Yeah.
a fractions, not a decimal. So these are called integers. So if we are writing, if we are saying only integers, that includes both positive and negative integers,
But
including
natural
0.
numbers only include positive.
Yeah, that's right. And natural number, that is only positive integers, right?
Okay.
And there are a few more types that we used to say whole number that starts from 0, 1, 2 onwards. So natural number including 0, that is whole number, and natural number starts from 1 to onwards, that is natural number. And integers means it starts from negative including 0 and all natural numbers, that is integers. And we used to write with q, that is rational numbers, all those numbers which we can write in form of p over q. P over q means either it can be a fraction, or if I'll say it's a 0.2, we can
Yeah.
easily write that is 2 over 10, or you can say it is same as 1 over 5. So this one is a rational number. So as you can see in the diagram here, so natural numbers, all natural numbers are integers. As you can see, it is inside natural numbers and is inside all these the oval. So all natural numbers are integers, all natural numbers are rational number, all natural numbers are the real numbers. So you need to identify which category is particularly it goes. So natural numbers, integers, rational numbers, and real numbers. So all numbers are real numbers. You will divide in two categories, rational or integers, and whether it's a natural. So like that, we can identify which category is most suitable one. So
So
here,
0.7 rational numbers would be the best for it.
yeah, that's right. Very good. So 0.7, it is the best to define is a rational number. How
Uh,
about, yeah,
1.3 reoccurring, that would also be a rational number.
that's right. Perfect.
-1 would be an integer.
Yes.
Wouldn't E be outside?
E, all these like numbers, whether it's a non-terminating like E is a irrational number. As we know that irrational is also a type of a real number, right?
Okay,
So
so it just goes for a real number.
yeah, that's right.
3/4 would be a rational number.
Yeah, that's right.
Uh, I would say square root 2 and square root 9. Well, no, square root 2 would
Yeah.
go in a rational number, and then square root 9 would go in integers.
Yeah, square root 9 will go integers and square root 2, as you know that it keeps on going 1.41. It's non-terminating and non-repeating. So we'll
Mm.
say it is a real number. It is not rational. We cannot write in the form of P over Q.
Oh, okay.
And square root 9, it comes 3 since it is a perfect square. So it comes in the category of integers, as you said. And how about pi?
Pi, would that be a real number?
Yeah, that's right. Since pi is irrational number and
Yeah.
it goes in real number.
Wouldn't that make
So
1.2 reoccurring a real number?
yeah, 1.3. See, 1.3, can you write in terms of P over Q? Can you write in this form?
Oh yeah. I mean, I don't know how to, but I've seen that you can.
Yes, you can. So let's how you are going to write it in the form of P over Q. Let's assume this one is 1.33 like that, right?
Mm-hmm.
So if you'll multiply it by both sides by 10, that's going to be 10x and it's going to be 13.3333, right? It keeps on repeating, right?
Yeah.
Let's subtract it. The first equations from the second, that's going to be 9x and 13 minus 1, that's going to be 12. So x is going to be 12 over 9 and just you will divide by 3. So that's going to be 4 over 3. So 4 over 3 will be 1.3 recurring. So
Okay.
this is the way of writing the recurring number in terms of a P over Q. So what we did here, since we know that after decimal 3 keeps on repeating, only one number before the decimal, that is 1, is unique one. So that is why we multiplied both sides by 10. So the left side it became 10x and the right side it became 13.333 again. So when we have subtracted these two equations, we got left side 10x minus x, we got 9x and 13.33 minus 1.333 up to the infinity. So 13 minus 1, that is 12, and 12 over 9, that become 4 over 3. This is the way of converting the recurring number into the P over Q means a rational form.
Okay.
You might be knowing, right? Okay, so let's see the about the surds. Now we are going to learn what is a surd. Surd means simply any irrational number which is not a perfect square. You cannot remove the root. It is actually a root, but it is not a perfect square root. Like square root 2, it is a irrational number. You cannot write in either in the form of integers or in a perfect number. It is irrational number. So simply you can say all irrational numbers are in the form of surd. So here you can recognize square root 2 is a surd because we cannot write in the we cannot remove the square root, so it must be a surd. How about square root 9?
Square root 9. Not a surd because you can.
Yeah, it's not a surd.
And then square root 5 would be a surd.
Yeah, that's right.
Mm, think it's a surd?
1 over
No, no,
4.
it's not. No, it's not. It's not.
Yeah, it's not. Yeah. And how about cube?
That
Cube
is a
root,
surd.
yeah, it's a surd. So simply we can define the definitions. The surd is a root of a number that cannot be simplified to a rational number, or you can say all irrational numbers are in the form of surd. Okay, so let's see. The main, there are two more most important rule of the surd we have. Let's see the what are the laws we have. There are two laws. If there would be a square root a multiplied a square root b, we can write in this form. That's a square root ab. So we can write in this form to simplify it. And one more rule we have, if it would be a square root a over a square root b, we can write it that is a square root of a over b. So we can write in this form, that is square root a over b. Both are equivalent. There's no difference at all, whether it's a individual square or whether we are taking the square root of all together. Here
Okay.
it's the same thing, individual square root or square root of the fractions a over b. So if we are going to multiply these rules to simplify this one, so how much is going to be? Square root 3 multiplied square root 2.
Uh, I would think that's square root 6.
Yeah, that's right. It will be a square root 6. How about square root 1 over 9?
Have no idea.
Okay, as you know that 9 is the perfect square, right? Square root of 9, that is 3. And 1 is also a perfect square, right?
Oh, okay.
So that's going to be a square root of 1, that is 1, as a square root of 9, that
1
is
over
3.
3.
So 1 over 3,
Ah, okay.
right? Like that, we have applied the second one.
Okay.
Okay, how about the last one?
Um, uh, I have no idea.
Okay, so let's take the individual one. Since if there is a square root of 4 and x squared together, we can separate it like a square root 4 and a square root of x squared, right? As we
Ah,
know
okay.
from this rule. So a square root of 4, we know that that is 2. And a square root of x squared, that is x.
Yeah.
So we can say it is 2x.
Ah, okay. That's actually
Yeah,
quite easy.
yeah. So like that, we can write it. Okay, let's see the, if there would be a complete square, there is only one term. So how you are going to simplify it? Like a square root 8, you need to write in simplest form. So what will you do here?
Square root of 8 and make it in the simplest form.
Yeah.
I have to admit, when
So
it comes to surds,
okay,
I'm pretty
okay,
like,
okay. Let's see. You need to find like a 8. We know that. You need to look at this number in such a way that is there any number which is a factor of 8 and perfect square. So you can write in this form. 4 is a perfect square. 4 times 2, that comes 8, and it is a square root, so it will be a square root. Now we will separate it applying the first rule, square root 4 and square root 2. And since square root 4, it is 2, and square root 2 will be as it is. Are you getting it?
mm-hmm.
So what we did, we found the, is there any number which is a factor of 8 and also a perfect square. So we know that 4 is a perfect square. So that is why we have taken the factor 4 times 2, that is 8. So instead of 8, we have written 4 times 2, that is 8. Now since it is a square root of 4 times 2, we can separate it. We can do the square root individually. And now square root of 4 is 2 and square root of 2 will be as it is. So this one is in simplest form. So we can write in this form and like this.
Okay.
Yeah. So by applying the same method, so can you say about square root 27?
Yeah, so it'd be square root 9, square root 3,
Yeah, that's right.
and then it'd be 3 square root 3.
Yeah, that's perfect. Mm-hmm.
That makes a lot of sense.
Yeah.
Then
How about next one? Yeah.
square root 4 square root 8.
Mm-hmm.
Could you square root the 8 even more?
Yeah.
I mean, could you simplify it? You can, because would that go? So so that would be 2, and then so do we simplify the 8 down even more?
Yeah, yeah. Here I have written in a note, as you can see, we need to find the largest square factor. Like instead of taking 8, 4 times 8 like that. So what will you do in a short form? 16 is a perfect square. So you will be taking 16 times 2, right?
Oh
A
yeah.
square root of this 2 and square root of 16, that is 4, and this would be 4 square root 2.
Oh, okay. So instead of doing
So
4,
you will be finding the largest number, which is a factor of 32.
okay. So
But
50 would be 25 and 2, and you
yeah,
could
yeah, that's right.
it'd be 5 square root 2.
Yeah, that's right.
Okay.
Mhm. So like that, you can easily do for this as well. Okay, let's move on. If there would be a number like these type of number, you can do in the same way. Like you will be thinking of the largest number and whichever will be the perfect square, you will be taking it. So let's see the next one. If there would be a multiple of surds like a 6 times square root 20. So since 6 is already outside the surd, so you are not going to do anything. Just you will think about the number to simplify, which is inside the surd, means inside the square root. So like as you did before, 6 and inside you can write 4 times 5 and 4 is a perfect square. So 2 will come outside. We can write 12 square root 5. So that would be after simplification. You will be getting this one is 12 square root 5. So here will be 12 square root 5.
That one I don't get.
Oh,
I've
yeah,
got
done.
one previously, but how do you get from 6 square root 4 times 5 to 12 square root 5?
Okay, okay, just wait a minute. First, think about 20, right? Let's leave 6 as it is. So as
Okay.
you know that if you are going to simplify it, we are going to find the largest factor of 20, which is a perfect square. So can you say which is the largest factor of 20 and also perfect square?
Um.
4 is the largest factor, which is a perfect
Oh,
square,
oh,
right?
perfect. Yeah, yeah, 4. Yeah, 4 and 5.
And we
Okay.
can do it individually instead of having a common square root of all. So a square
Okay.
root of 4, that is how much? 2.
Yeah.
And
Inside
a square root
square
of
root.
5 will be as it is. Now,
Yeah.
if there is 6, so 6 will be as it is since it is in multiplication, right?
Oh, and
So
6 times 2 is 12.
yeah, yeah,
Okay.
that's right.
Yeah, that makes sense.
Mhm. So this is the way that we'll be solving the number which is already outside the surd. We will not be doing anything at the end. We'll be multiplying it to make it in simplest form. So
It
let's
says
do for the
it says
second.
square root. It says square root 3 though there.
Oh, sorry, it's my mistake. It will be 5. Let me change it. Wait a minute. It's not. Must be 5.
Okay.
This. Okay. Okay, let's solve for the second one.
Okay. So, um, 4 and 3.
Yeah,
That
4
would
and
be it.
3, that's right.
Yeah. And then you'd move on to,
Mm-hmm.
so you could square root it down to 2. Would it be 14 square root 3?
Yeah, that's right. 14 square root 3.
Okay.
Similarly, we can do for the next one, right?
Yeah.
Hmm.
9 and 5.
Yes, 9, 5, that's right.
So you could square root them both down. You could square root 9 down,
Yeah, that's right.
3. So it'd be 6 and 5.
Yes, you're right.
6 square root 5.
Yeah, that's right.
Okay.
Okay, this is the way that how you're going to simplify it. If there would been multiplication, this is the same as before you did. So you can do the in the next way. So the next the rule is instead of having the one square root of a number, here we are having a mixed number, like a square root of both of the numbers. It's a multiplication of the surds. These are the mixed form. So just you need to write in a standard form after doing the simplification. So let's do the simplification of the first one. So as you know that it's an individual square root. To write in simplest form, you will be multiplying inside one square root. So 3 times 5, and it's going to be a square
15.
root of 15, right?
Yeah.
How about this one?
2 times square root 3.
Mm-hmm.
That would just be 2 square root 3.
2 square root 3.
Yeah.
Okay. So 2 square root 3. Suppose if you are going to write only one term in form of surds. So how will you write in forms of surds? If you are going to write this one in form of surds.
Um, I'm guessing it. What, square root 6?
Square root 6? No.
Then I'm not really sure.
Okay. So here, so far it's correct one, but I'm just asking you are going to write in form of surds. As you know that 2 is a square root of 4, right? So 4
Yeah.
times 3 will be writing inside 12. Can you?
Oh, I see how you got there.
Okay, yeah, that's right.
Okay.
So if there would be the number which is not a square root, then you are going to do the square it first and then you multiply it. So this one is a 2 square root 3, just it's a multiplication. But if they will be asking you to write in form of the surds, you will be writing a square root 12.
Okay.
But here just they are asking you to multiply. So here is 3 square root 5. Here you will be multiplying. Let's multiply the second last one.
The second, it would be 16. Oh no, before the square root. No,
Yeah,
no,
that's right.
4.
Yeah, it's 4. That's perfect. Yeah, 4.
And then the next one would be 3.
Yeah. So good. Okay, now let's multiply these numbers.
Multiplying surds. So, is it possible?
Okay.
Four, maybe it's like four square root 15.
Yeah, that's perfect. 4 square root 15. That's right.
Okay.
How about second one?
That would be 3 square root 2.
No.
Because wouldn't you? I mean, I know it's
Three.
9, but wouldn't you square root that?
So it's going to be 18, right?
Oh, yeah, it would be 18. Yeah, my bad.
Okay, let's do the last one.
I, don't you times 18 times 2, which would be 36.
Yeah,
And you square root that to 6, and then 6 times 4 is 24.
24. That's perfect. Yeah. So this is the way that you're going to multiply those numbers. Okay, so like that, you can do is similar questions we have. You can do it easily. So if there will be these kinds of exercise, you can easily do that. Let's do randomly. So let's do square root 80. How much it should be?
Square root 80.
Yeah.
That would be. Let me just think. I need to find the highest. What's it
Yeah,
called?
highest perfect square factor. Highest number which is a perfect square.
Just trying to think what the highest number is.
Yeah.
Brain is not working today.
Mm.
My brain is not working today.
It's working. Why are you saying it's not working? You have given so good, so well answer you have given so far.
Actually, yeah, I just can't think what the square root is. I mean, what would be a perfect square root number?
Okay, yeah. Let me explain you what is a perfect square number. Like it starts from 1, like a 1 square is 1,
Oh no,
4.
I understand what a square root number is. I'm just trying to think which one it is. And
Oh, okay.
is it 16?
Yeah, 16 is. Yeah, that's
16.
right.
Right. So
Mm-hmm.
that would be 4 square root 5.
Yeah, that's perfect. See, you are so good. You just within a seconds you thought it. Okay. Let's do the like that. All are similar questions. So let's do the last one. Three number first.
Would you
Like
just times
square
them?
root 3, square root 2, square root 5.
Yeah, wouldn't you just times them all together? So 30.
Yeah,
Square
that's
root 30.
yeah, that's right. So that's going to be a square root 30. Since no one is a perfect square and we cannot make it as a rational form, so that's going to be a simply a square root 30. Okay. Now here would be like a number. If there is a number in the form of like a little complex one, but you can write as a single form. Here it says that write in one number form instead of having a many numbers. So if there is a 3 square root 2, so can you write in form of one single square root?
One single square root.
Yeah.
Mm,
Like as you know that 3 is the square root of 9, so it's a square
yeah,
root of 9 and a square root of 2. You will be multiplying together. That's going to be a
18.
square root of 18. So
I was
like
thinking, I was thinking of doing that, but I just wasn't sure yet. But yeah,
okay, let's do the 5 square root 7.
okay. Um, so wouldn't that just be 25 times 7,
Yeah, that's right.
which would be
175, yeah?
Yeah, 175.
Okay, let's do the 6a. Here it says that a is square root b. So you are going to write same as you did in question number 5 as a single square root. Here instead of a number you are having a variable. So how you are going to write in form of a single square root?
Yeah.
How will you write?
Same as, uh, square root a squared
Yeah, that's right.
times b, a
Yeah,
squared b.
yeah, that's right. Square root a square b.
Yeah.
Yeah. How about the last one? 6b.
That would just be square root 4k.
Yeah, that's right. So good. So these are all about surds you have. So it depends on, they will be saying two types of whether you are going to write in the form of simplified form or you are going to write in a surds form. This one is a single square root, that is a insert form. They will be asking you to write in this form. Now let's see how we are going to add the surds. Like simply, as you know that if there will not be a surd, like 2 plus 2, we know that it is 4, and like 1 plus 1, it is 2. So it's
Yeah.
the same as we are going to add it. So square root 3 and square root 3, there are two times we'll be writing 2 square root 3.
Okay.
Yeah, so like that we'll be adding it. So can you see that? How about this one?
Wouldn't that be 3 square root 5?
Yeah, that's right, 3 square root 5.
And then the next one would be 14 square root 7.
Yeah, that's perfect.
And then they're two different numbers.
Yeah, two different numbers. So to add the surds, what you have to do, you always have to convert in like form. Like as you can see here, both were having square root 5, square root 5. Both were having a square root 7, a square root 7. Then you have added. Here you have a square root 2. So you need to convert either of these two in a single form. Like square root 8, usually we go higher to lower. So square root 8, you can easily convert, that is 2 square root 2, right?
Yeah.
And then you are going to add square root 2. So it's going to be how much? 3 square root 2.
Okay, 3 square root 2.
Yeah.
So that would just be 4 no, sorry, yeah, 3 square root 2. Yeah.
Yeah. Let's think about the last one, which one is a mix of all these three.
Okay. So you'd have to simplify 27 down to. Can't you simplify both of them down to something?
Yeah, you need to
3?
simplify both here because you cannot, 12 is not a factor of 27. So you are going to simplify down to 12, 12 to the lowest number and even 27.
Yeah, wouldn't you simplify them down to 3? To
Yeah.
3s?
Yeah.
So that would be 4. So 7 3s. 7 square root 3 plus 9 square root 3.
Mm-hmm.
And then
Okay, let's do individually first. Let's break it down. 3 square root 12. We can write it 3 square root 4 times 3. So square root of 4, it is 2. And 2 times 3, that comes 6 square root 3, right?
yeah.
Okay. And similarly, we are going to break it down. The 27, that can be written as square root 9 times 3. So square root of 9, that is 3 square root 3.
Okay.
Now we will add these two. That's going to be 9 square root 3.
Okay.
Yeah. So always you need to, before adding the surds, you have to convert in like form, means which must be of the same type. If these two are different, you cannot add it. Suppose if the number will be like a square root 2, let's erase a square root 2 and a square root 3, you cannot add it anyways. It will be as it is. You cannot do anything in this because it's already in lowest form, right?
Yeah.
Okay, so these are the example you have. Okay, now let's see if there would be a bracket inserts. So how you are going to break it down? You have to write in simplest form. So let's start with the first one. Since you know that if there will be a bracket means multiplication. So to simplify it, you are going to expand the bracket, right? So if you'll expand the bracket, just you will do this multiplication. Square root 2 times 3, you can write 3 square root 2. Since it's a convention to write the integer number before the square, so we have written 3 square root 2, and then we are going to multiply square root 2 with square root 2. That's going to be 2, right?
Yeah.
So this will be your simplest form, or you can say in the form of simplified number. So after simplification of the surds, you got 3 square root 2 plus 2. Okay, so can you simplify the next one, this one?
Yeah. Two. I'm probably wrong here, but I somehow got to 2.
2?
I'm sure.
No, it should
Yeah.
not be 2. After
Okay.
simplification, it should be 1.
1.
Yeah. Okay, let's see how it is. Let's multiply here. Just we have multiplied. So square root 2 times square root 2, we got 2. Square root 2 times minus 1, we got here minus square root 2. Again, we are multiplying 1 times square root 2, we got plus square root 1 times minus 1, that is minus 1. So minus root 2 has gone. 2 minus 1, that is 1.
Ah, okay.
Yeah. So just it's a simplification. Okay. So let's do the next one.
Okay. 8. Just gotta write this down.
Just be careful to multiply, because if you will do something wrong while multiplying, the entire result will be wrong.
Okay. So first we gotta do I have to simplify the 8 down?
Yeah, you need to first simplify square root 8 and then multiply it. That will
So
be more easier for you.
okay, so it'd first be 2 square root square root 2.
Yeah, that's right.
And then plus 3 bracket blah, 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 and then all of that.
Yeah, that's right.
Okay, I don't really know what to do from there then.
Okay, let me
Yeah.
do it. Okay. So You have already written this is 2 square root 2 plus 3, and here it will be as it is square root 2 plus 5. Let's multiply it. So if you're multiplying it, 2 square root 2 multiplied with square root 2, that's going to be 4, right?
Yeah.
And then we are going to multiply with 5. 2 square root 2 multiplied with 5, that's a 10 square root 2. And then we are going to multiply 3 with each of these terms. So 3 times square root 2, that's going to be 3 square root 2. And then we will multiply the last one. So 3 times 5, that is 15. Now we will go with the like term, integers with integers and the irrational number with the irrational number. So 15 plus 4, that is 19. And 10 plus 3, that is 13 square root 2. So this one is your simplest form, 19 plus 13 square root 2.
Okay.
Yeah. So here you have the things, 19 plus 13 square root 2.
Okay.
Okay, can you do the last one?
Yeah. As it's squared, wouldn't that just be 5 minus 4?
No.
Because you're square rooting the 5 root.
No, if the way that you are saying, if that would be like square root 5 square minus 2 square, then it would be 5 minus 4. That is
Oh,
1. But it's a complete whole square. Whole square is different. Like
okay.
a minus b square means same as a minus b and multiplied with a minus b.
Okay.
Yeah.
Okay. Um, hmm.
You might be knowing there is a rule that is called FOIL. Do you know this rule?
FOIL.
Yeah.
I've not heard of it, no.
Oh, you don't know? It says that first out and inside last. What does it mean? Let's see. Like when we are writing a square root of 5 minus 2 whole square, that is in if we are going to write in expanded form, that's going to be a square root of 5 minus 2 multiplied with itself. So it says that first we are going to multiply outside one, means first we are going to multiply with 5 with 5, square root of 5 with square root of 5, and 2 with the 2, means both are like a outside with outside. So a square root 5 we are going to multiply with a square root 5, that is 5. And now we are multiplying minus 2 with the minus 2, that is plus 4. Okay.
Yeah.
So this one is up to FO, that is first out. All those numbers, those who are at the end, like a square root 5 at the first and the last, the 2 one. So we have just multiplied outside of one, a square root 5 with a square root 5, 2 with the 2. So that is why we are saying first we have multiplied outside one, those who are at the extreme position. Now inside last, we are multiplying inside last, means We are multiplying, here's square root of 5 with 2 now, and then here inside the last one, square root of 5 with minus 2 now. So if we are multiplying square root of 5 with minus 2, and again this inside one square root of 5 with minus 2, we are getting minus 4 square root 5. It means 9 minus 4 square root 5. This one is here. Let me explain this one. FOIL. You didn't get. Let me explain once again. Let's see this. A minus B. We are going to multiply with A minus B. So
Yeah.
we are going to see that the first FOIL. So we are going to multiply first with the first outside one. Means A with A and B with B. Okay.
Yeah.
So A with A, that is A square, and B with B, both are negative. So that's going to be plus B square. Okay.
Yeah.
Now we are going to say that inside last. Now, since we have already completed outside number, means A with A and B with B, both are like at the extreme positions. So we have multiplied it. Now we are going to multiply with this A with this B and this B with this A. So
Okay.
once you have multiplied with this A with this B, you got minus AB. And when you have multiplied this B with this A, again you got minus AB. That means A squared plus B squared minus 2AB you got. So this is the way of multiplying. Like just you need to keep in mind that usually in multiplication, we follow the FOIL rule. So it will be more easier, like you can see that whether you are multiplying each individual terms with the others or not. So you can easily identify it. Okay. So let's see what are those. Okay. So here we'll be doing the same thing. We have expanded it and we have multiplied each outside numbers like square root 5 with square root 5, we got 5. And we multiplied minus 2 with minus 2, we got 4. And then we multiplied minus square root 5 with minus 2 and minus 2 with square root 5. So we got these two intermediate numbers. And after simplification, we got 9 minus 4 square root 5.
Okay.
Yeah. Okay. So there are more numbers we have to test and you can do the practice. Here you also having the things how to do the find the areas when these numbers will be given in terms of surds. You can easily find it out. So there are many more practice questions you have. Okay. Now there's other parts of doing the surds where it will be often asked you to, apart from the simplification, they will be asking you to rationalizing it. You need to rationalize it, how you are going to do that. Let's see an example here. Like a square root 5, if you want to rationalize it, you need to multiply with the number itself. Since a square root of 5, it is a irrational number, so you must have to multiply with the same number, then only you will get the rational number. Rationalizing means you have to obtain a rational number, and rational number, you know that must be an integers or like fractions like 1 over 2 like that. It should not be a square root, right? So if it is an irrational number, you have to think by which number you are going to multiply so that this number is going to convert it into the rational form, means in a rational number. So obviously Here, since square root of 5, and if you multiply with the square root of 5, you'll be getting the rational number that is 5.
Yeah.
Okay, how about this one? Like 1 over square root 2, by which number you will multiply so that you will be getting a rational number?
I would imagine just 1 over square root 2 again.
Yeah, that's right. That's right. So you are going to multiply with the square root 2 or square root 2. So you are getting the square root 2 over 2. So denominator, if you want to get the rational number, so you have to multiply with the is 1 over 2 and 1 over square root 2. But since this one is a fractions, if you'll multiply with this number, so what will happen? The number is going to be changed. It's 1 over 2. But we have to keep the fractions in the same ratio, right?
Yeah.
So here you can multiply the square root 2 with the square root 2, both denominator and numerators, so that the simplest form will be square root 2 over 2. That is called in a rational form, means rationalization. So like that, you can do the simplification, doing the converting in the rational form. Let's do the first one. You are going to convert into the rational form. 3 square root 2. 3 over square root 2.
3 over square root 2 would be sorry, is this what I should what am I writing what I should times it by to make it a rational number?
Yeah, you need to make a rational number.
Okay, so I would times it by 3 over. I just times it again by 3 over 2 squared.
Yeah, so here's a 3 square root 2. So you need to multiply, since square root 2 is an irrational number, so you're going to multiply by square root 2 and square root 2. Since you need
Oh,
to convert, yeah, this one
okay.
in rational form. So you are getting 3 square root 2 over 2. So this one is in rational form. Yeah.
So I'm guessing the next one would basically be the same with square root 3 over square root 3.
Mm-hmm. So can you do the simplification after that?
Yeah, that would be 3 square root 3. No, 6 square root 3
Yeah,
over
that's right.
square root 3. I mean over 3.
So after simplification, it will be how much?
It would be 6 square root 3 over 3.
So we can write 2 square root 3, right?
Yeah. Oh
So
yeah, you can simplify
yeah.
it down. Yeah, I didn't realize that.
Mm-hmm. So wherever like there would be a possible to simplify, we will do the simplification to write in always simplest form. Like that, can you check out for 8 over square root 10?
8 over square root 10 would be square root. So you times it by square root 10 over square root 10.
Mm-hmm.
And that would amount to 8 square root. 8 square root 10 over 10.
Mm-hmm.
Could you simplify that down? I don't think you can. No, you can't simplify that down, can you?
Yes, you can simplify.
Um,
2 is common between
oh,
8
two,
and
two.
10.
Yeah,
Yeah.
that's it. 2. Yeah, of course.
So that's going to be,
4 square root 10 over 5.
yeah, that's right.
Okay, yeah, of course, 2.
Let's do the next one. You can say the last one. 7 over square root 7.
Um, that would be square root 5 times square root 5 over square root 5, which would amount to 10 square root 5 over 5, which would equal to 2 square root 5 over
Yeah,
1.
that's perfect.
Over,
Yeah, that's right.
yeah,
Yeah.
over nothing.
Okay, so this is all about surds. We are having a little more complex questions. Like here we have seen the only one number it was, whether it's a fractions, whether it's a irrational number, when there would be combinations of like a square root 2 plus a square root 3 over square root 5 plus square root 3, and they will be asking you to rationalize it. So what you will be doing it, we'll be learning in next class how to simplify them when there would be a little more complex surds, and we will be learning how to make it simplest form. Okay.
Yeah. Okay.
Okay, that's all for today.
Can I just ask? Do you remember the lesson we did? The last lesson we did. If
Yeah,
you're, yeah. Do you possibly still have a video for that?
yeah, video is there. Yeah,
Is it?
I'll download and I'll share with you. Okay.
Is it alright to share that with me? Because
Yeah, yeah, sure, sure.
yeah. I understand. I just need to. I think I just got to keep refreshing myself to that
Yeah,
subject.
yeah, yeah, sure, sure. I'll share it.
Thank you.
Welcome. Okay, bye.
Bye bye.